So SQL is definitely one of the most powerful tools that you must learn, you must know. Not even some, every company, every business must have a database where they store their data. Excel is not a database. Excel is just a spreadsheet. Power BI is not a database. You cannot store data there. It's just a visualization tool. But SQL is a database. So every company needs to store so that when you go back, like the way it used to be in the olden days, people store their data in oh sorry, let me share my screen. In the olden days, people store their data in manually, the way they used to store data manually then. So I don't know, let me see this one. So manually, they used to store their data manually then, where you can have even when if you go to a school, maybe a department, a particular department, you see heaps of files. They will keep files. In fact, they have to keep for each year student of 1980, 1981, 1990, 1991, 1993, 2000. So if you graduated from 2000, and maybe let's say you graduated in 1995, you can go back to your school and you need any information, they will have to go and start searching for those files of each of the year. But there's a way they classify it. They will just put it in maybe a drawer or a cupboard. They will label it this 1995. They can just go there and get all of those things. So those are databases. Those are the manual way that people used to manage data. Then database. But recently, things have changed because back then, I remember one time when we were doing our project back then in school. We saw that our department at a point wanted to do cleanup because the whole place was messed up, was filled up with old files from years back. So at a point, like the projects so many people did in so many years ago, they still had those projects because they tried to keep all of those things safe and secure so that in case any student from way back comes back to say they need to so thing, they can always provide it for them because it is their own duty to provide whatever information any student from any year needs. So, but sometimes when I saw that departments were decluttering, they will pack out all of those things and dispose them. Sometimes they'll pack all of those things and burn them, just to create more space for newer students. And it's very risky because a student from way back can come back anytime and request for any information, and they don't have it. Maybe they've burnt it, or it becomes a problem. And it could be that that particular thing the student is asking for is something that they need, that's very critical to their current situation, maybe in their workplace, or they're applying for maybe a school or something, or they're applying for a PhD program or something somewhere. So, but recently things have changed. People are no longer storing data that way. There's now computers where you can store data, and you cannot just, compile this data and then save them in a folder in your computer. It's risky as well because your system can get stolen, it can get lost, it can even crash to a point where you need to format everything and then you still lose those information. And that is where, and then if you feel that okay, I can store them online, I can upload them to maybe a Google Drive or something, remember you're paying for space. Each Gmail account you open, Google always give you 15 gig for free to store. And when you store so much data, like you now, you have all of your data, all of your information or your document, your necessary documents uploaded online to your Google Drive so that you can access them remotely from anywhere. It's no longer those days when you need to submit an application. You need to run back to your house to go and get your certificate, to go and get your probably your CV or anything. Then you come back, or maybe if you're in a different city, you have to call someone at home to send them to you. No, these days you store your information on your Google Drive. You upload them to your Google Drive. You have your data, your certificates, your whatever, your CV, anywhere, even from your phone. You can access them from anywhere in the world. But now, Google gives you only 15 gig per Google account. So if you exhaust that, you can now start buying more space. Like you can literally buy 50 gig, 100 gig, and all that to save more information. So it's also very expensive having those information it for you online. Now imagine you as an individual, you need to buy all those space just to save your files or your save your documents or save important videos or pictures or something. Now imagine a company, imagine a company like Netflix or Amazon that records millions of data per second. They get customers. Amazon get nothing less than 1,000 orders per second or per minute. So, and they need to keep all of this record. Imagine a school, a university that admits hundreds of thousands of students per session. They have all of a very huge data to handle, and that is where database comes in. That's where database. They need to have a database where they store all of this information permanently, forever. It's stored there. They don't have to worry about space or anything. SQL is a database management system. Now, this is the reason why you need to understand, because uh, there's nothing like data without database management system where you can store this data. Wherever you're going to be working, no matter the kind of whether it's a hospital, no matter the kind of company you're going to work for, they definitely have a database. No, as a data analyst, you may not actually be doing much with the database. Yeah, you may not be doing much with the database because you're not the one creating the database. You're not the one manipulating the database. You're not the one um, handling the database. You are not the one that is in charge of deleting or adding information to the database. Your own job is just to get data, just to query the database and get the information you want to work on or the data you want to analyze, and then proceed to what you want to do with it. Okay, so you're not really the one that's going to design. There are database engineers, there are database administrators, there are people hired to do all of these things, but you need to understand how this database work for you to be able to get what you need from it. And that is what we are going to. So today, in today's class, we are just going to clear off all the um all the theoretical part of this SQL. May not be going into writing queries today, but we may actually write a query, one or two, but that's not what today is. So I just want, just like we always do, we did that in SQL, in Power BI, and in Excel. We clear off all the theory. Then when we get into practical, we'll now go deep and know that we are in. So now, what is SQL? SQL is structured query language, sometimes pronounced as SQL. So most times you'll be hearing SQL, SQL language, SQL scripting, SQL. It is the same thing as SQL. The name is just from the way it sounds, SQL, SQL, you get? So there's really no big deal about it. But what you want to know here is that S stands for structured, Q stands for query, and then L stands for language. So it's a programming language that you use to write scripts. Is usually a query language. You use it to query the database, okay? Then sometimes it's pronounced as SQL. It's a domain-specific language in programming and designing for managing data held in a relational database management system called RDBMS. So RDBMS will have the relational database management system. This RDBMS simply, we are going to go deep into it as we move on, but it simply means we have two type of management system. We have the DBMS and the RDBMS. So the DBMS is simply the database management system, and the RDBMS is a relational. You add relational to it. So what this R mean when you're talking about DBMS, it means you just have a database and nothing else. But when you add R, it means you have relational. It means you have a database that's relational. That is, all the tables are relating to each other. You can relate this table. You can even join two tables together. You can even join multiple tables together in that. So SQL is kind of is a relational database because it allows you to relate different tables in that database. In our previous classes, I mentioned to you about table relationship. I think we talked a lot about that. Structured query language is a standardized programming language. So let me quickly take you to Excel. Let me explain this RDBMS. So in case we don't come back to it, Though I've explained it a couple of times. So you can see here, let me convert these things to a table. So you can see here that we have these tables. Um, this is something we've done a couple of times, for just for context sake and for your own reminder. I want to do it again. So now, if you just like we already know, SQL is very, very strict when it comes to tables. All right. Now, this is the table. This is the general table that has all the information you need. This is the table that you have. You can see it has the order ID, the order date, and all this information. Now, you cannot put this table like this inside SQL. You cannot put this table here like this. Now, the reason is because you cannot it is going to, number one reason is that, like I mentioned in one of the class previously, when you're storing information, remember this database is stored somewhere in the cloud. All right, it's stored somewhere abroad in the cloud. So it is not something in your computer or something you can see. It is in the cloud. There are companies that are actually in charge of managing database, like Microsoft, for example. There are so many of them. So for you to have this database, you have to pay. It could be that you're paying per second or per minute. So if you now store the more space you take, the more money you pay. So if you now have your data and it's so big, to big table, large tables like this, it will take more time. It will take more space in the cloud. So you're going to be costing your company more. The company is going to be paying more money to have their data stored and all that. And because the table is so big, each time you want to add new data to that table, you have to go and add, you have to kind of pull out the entire table and add data to the table, and you're paying for each time you're working on the table on the internet, on the cloud. All right. So whichever one you're using, whether you're using Microsoft, whether you're using Azure or any other of them. And then another reason is because when you want to now modify information, for example, let's say anything here has changed, you have to go to the table, and remember this table have thousands of columns and hundreds of rows. So just because you want to save, let's say you want to change my name now, maybe I moved from Nigeria and now relocated to maybe UK. I just moved to UK and I am placing so many orders in this table. So you have to go to everywhere you have Chris in this table and change the allocation now to UK, the country. Or let's say address, maybe it's my address. My address I've even if I'm still living in Nigeria, maybe I was living in Abuja and I've now relocated to Lagos and I have a new address. You have to go and start changing every single place I have it in the table here. And that's going to be tedious. It's going to take a lot of time to do. But instead of that, you can just come to the customer table and change just where you have my name, just change it, and that's all. It will reflect in the database. So it takes you just few seconds to update this. So let's try to understand the table we have here. This is the big table that has all the information, right? And then this is the way it should be. This table now has all the whole observational units. It has the customer order. This is talking about order, the order date. This is talking about the quantity. This is talking about the price, the sales. This is talking about the customer, the product, the store. So it has a lot of observational units. But before you can move this data to SQL, you have to break it down, separate, pick out the customer information, and have the customer table. So this is the customer table. You have the product table. You're going to store this as a customers table. Then you're going to store this as a product table. You're going to store this as a store table. If you have other table, you can also store it maybe as a whatever, any other table you have, order table. You can have sales table. You can have payment table. You can have transactional table. They have to be in different units like this. All right. So this is going to help you to Remember when we wanted to change my address? Because I changed my address, I can just come to this place and change my address just once, and then you're done. Instead of going to the big table here to start changing the address individually, or trying to use a function or a formula to change this thing in the big table. But just come here, change it, and you're done. And you're done, and that's it. So, for example, if this product is now out of stock, you just want to come here and update it that it's now out of stock. Simple. It's easy. Now, because you're working on this table, this is just the table you're working on. You have no business with this other table. You don't have to call up this table. You don't have to call up this table. If you remember one time when ChatGPT came up, we had the ChatGPT Open AI. So your ChatGPT so this was ChatGPT. When they built this ChatGPT, it was built in the USA, and it cost a lot of money. 10, was it $10,000, 10K plus whatever, 100. It was a lot of money that I cannot remember right now. But this cost a lot of money, 100 plus of dollars, 100K plus of dollars to build ChatGPT in the USA. Then in 2025, when Trump came in, China built their own. This was built in USA, right? It cost a lot of money. Then China now built their own ChatGPT called what was it called again? I've forgotten that name. It was just
DeepSeek.
recent. DeepSeek, thank you. So China built DeepSeek, costing only 6K or 6,000 or so. $6K. So everybody was now wondering, how come, how is it so cheap? It was so cheap that in fact it was like it was not even up to 5% of the money that was used to build ChatGPT that they built is, and it was doing the same thing or even better than ChatGPT. So the reason why it's like that is because ChatGPT was built, the model that they used to build ChatGPT were so many models, was just like all of these tables. Now, it was just like this big table here. That is the model they used. They used a model that knows mathematics, they used a model that knows physics, chemistry, medicine, engineering, business, history, all those models. They use all of them. So if you come here and ask ChatGPT how to cook rice, it will quickly activate the model that talked about food, and it will give you the answer. If you come here and talk about how to cure infection, it will bring up the model. They have a model about medicine. It will pick it up and talk to you about here. So ChatGPT knows everything that you can think of because they have model. They are constantly training all the models that knows all of this thing, professional in all this field. Now, this is what happens here when you come here and ask ChatGPT a mathematical question. Maybe you ask algebra or something. It will activate the engine. The engine will start working, and then all the model will rise up and start working, and then the one that knows mathematics will fix that problem for you and give you the results. It takes a few seconds. Now, if you ask ChatGPT about travel, it will activate all the model, and then until it gets to the one that knows about travel history, then it will come and give you. If you talk about ask GTP something that happened in years back, it will activate all the model until it gets to the one that knows about history, and then it give you the results. Now this is what now this remember, they are training hundreds and millions of models and knows a lot of things, right? That's why it's costing so much money. Now, this is what DeepSeek did when they came. They now simply took these ChatGPT models and bring them into different models, break them into different tables like this. This one knows physics. This one knows mathematics. This one knows history. This one knows chemistry. This one knows about food. This one knows about, these are different. They broke it down into different tables like this. This one knows about maybe relationship. This one knows about anything. So if you come to DeepSeek and you ask about food, please, what is the content, what is the nutritional value of rice? Now, this is what DeepSeek will do. It will just go straight to only the one that knows about food. and give you the results. Nothing concerns doctors here, nothing concerns travelers. All these ones will be sleeping, they'll be resting, they will not be activated. But if you go to ChatGPT and ask ChatGPT what is the nutritional content of rice, it will activate the entire machine. Everybody has to get to work, both doctors, lawyers, engineers, travelers, history, everybody, scientists, until the food scientists in here, the model that handles food, will be activated. Then that is one that will provide the answer for. I don't know if you're getting my point. Do you guys understand what I'm explaining here? Does anybody understand? Hello? Or is this ChatGPT boring all of you? Does anybody understand?
Yes, 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 sir.
All right, great. So
Understand, sir.
so now ChatGPT will wake up all the machine. Everybody will get to work immediately. Anything you type on ChatGPT, everybody, whether it concerns you or not, will get to work. So it is costing more money to run ChatGPT. It is costing more time. It is costing more everything, because even people that the question does not concern will get to work until they now see that, oh, it belongs to this person. Everybody will now rest, and the person it belongs to will answer it. But for DeepSeek, if you ask them anything, if you ask them anything about relationship, how to win a girl's heart, how to make my girlfriend happy, what is the best birthday gift for my girlfriend, it will go straight to only relationship model. These ones don't have to wake up. These ones don't have to. And each time these models wake up, they take a lot of space, they take a lot of time, they take a lot of money, they cost, to start working. So it will not activate the ones that it doesn't concern. All other models will be working on other people's query. So if 100 people are asking DeepSeek a question, only 100 models that are related, that knows about that particular topic, will be working, while the rest of millions of models will just be at rest. But ChatGPT, everything wakes up. So this is the reason why DeepSeek was cheaper, or is cheaper, while this one is more expensive. So you see, imagine you're working in a company. Each time you run a big table like this, it costs your company more money in the cloud compared to when you have a smaller tables like this. So this is why um this is why SQL imbibed this table relationship, this table splitting thing. This is how you store tables in SQL. Now, when you store these tables in SQL like this, let's go back to SQL. It says structured query language. It is structured. The table has to be. There are two type of table: the unstructured table and the structured one. Now, the unstructured table talks about like your movies. You cannot structure film, you cannot structure maybe music, you cannot structure those ones that you cannot structure. Those ones are unstructured one. It doesn't chat SQL doesn't have any business with those ones, though there are ways you can still store them. If you want to store them, you have to structure them. For anything to go into SQL, it must be structured. And what is a structured table? Let's see. Structured table are simply tables that are in rows and in columns. Once you see columns, row, those are structured. This is a structured table. This is structured now. This data is structured because you have them in rows, you have them in columns, they are structured. So, but when you have film, for example, movie, a movie now, that like a movie is actually a data. Movie is actually a data, but it's not structured because there's no way you can structure a film. Like it's when it's playing, it's just playing, or music, those kind of information. Right? There are other ways of storing them anyway, but SQL has nothing to do with those. Then once your table is structured, then of course SQL can handle it. Okay. So it handles structured query language. That's why it's called structured query language. You must structure your table before you can store it. It's a standardized programming language that is used for managing relational database and perform many operations on the data in them. So we already talked about relational, right? So now the relational here is that for all this table you're seeing here, they must have to be a way they relate. For example, if your manager comes in and say, okay, this order one, who placed this order? I want to know the customer that placed this order. Please get me the customer's information. All you need to do is just to come here and see that this table has order one. It has customer ID. Come to this customer ID, check the customer ID that placed the order is customer ID one. Then simply take this one here to the customer's table, and you see that the name of the customer is Chris and it's from Nigeria. You can even get more information about the customer, maybe their email address, their contacts, and all that, maybe their date of birth, or depending on the kind of information your company collects from customers. Okay. But with this simple order, this ID here, you can get the information about the customer. You know, say, okay, this is the customer. Fine. Okay, I want to know the product that was ordered in this order one. So you need to just come to the product. This is the product ID. Take the product ID, go to the product table, and you see it was a laptop that Chris bought on the 1st of September 2025, and he paid $80 for it. And that's it. So you can't, okay, you want to know which store location was the laptop ordered from. You now see order, you now go to store. This is store ID one. You can now check, oh, it was in USA. So maybe I ordered this laptop from Amazon, and Amazon store is in USA. So you can see it's in USA. Probably my order has been shipped or is on the way coming to me in Nigeria. Do you see the relationship now? That they are relational database management system. So we are managing the data in a relational way. They are related. So you can say, okay, who is the customer that placed order on the fourth order of that day? The first order, the fourth order. You can see there are definitely more information here, which this is just a sample data that I wanted to use to explain this to you. Who is the customer that placed the third order? You can see it was Cindy here from Uganda. Now, what did Cindy buy? You can now go to check here, go to products. You can see product 3 was what Cindy bought, and it was an iPad. She bought an iPad. Can you see that? She bought an iPad. And the store they bought it from, you can check the store ID is in USA. You can see. So the store is in USA. Probably she ordered it from Amazon or eBay or all of those stores in the USA. So do you understand what this is all about? I hope you understand it. So you can see that these tables, despite being separated, they are still as the same as this one. They are still the same thing because they are related. You can see the relationship and all of that. In fact, you get to a point when we get to what is it called? Join. You're going to learn how to join these tables back. Like you can join them, all of them back to have one big table like this again inside your SQL. There are different ways you can join different tables because some questions you may want to solve, maybe the information you need or the data you need is in a column here and a column in another table. So you need to bring these two tables together to be able to solve or to analyze some sort of data that you need to analyze. So you're still going to learn all of that. But this is basically just this basic concepts, theoretical concepts is what I want you to understand, that there's always a table relationship between these data, okay? Because SQL is a relational database management system. So any data you're working on has to be related. Any table you're bringing into your database must be related as long as they are a table in one database, okay? And remember, you can have multiple databases in one SQL account. So each of the database must have tables that are related in that database. Okay, so now let's proceed to know um, how really do we use SQL in database, how SQL is used in data analysis. Sorry, how do we use SQL in data analysis? SQL operate on tables. Remember, whenever you talk about SQL, you're talking about tables. There's nothing else it does. You cannot use SQL to to visualize data or do anything. The only thing you use it for is just to analyze, to get information, because Power BI cannot, those data you see that we upload to Excel or to Power BI, they are not gotten from the spirit land. You do not get them from heaven. You have to get them from a database. So it is definitely stored somewhere. So, and that database is SQL. Now remember there are different kind of databases you can use. You have the Oracle database, you have the SQL, you even have MySQL, and then you have SQL. You have I think MongoDB, you have Postgre. There are so many of them that you can use, but at the end they are all the same thing. They are all just the same way you have Power BI, you have Tableau, you have which other one? The other one I mentioned last time. That one is online. I think it skipped my mind now, but I have many of them. It's just for you to choose one that you're comfortable with. For spreadsheets, you have Excel, you have Google Sheets. You have many of them as well. So for SQL, you have Postgre, you have MySQL, you have SQL, and the most popular one is this MySQL that we're going to be using in this training. Okay, so SQL operates on table. So what you have inside SQL are all tables. Let me see if I have my SQL opened. Okay, maybe I'll show you before we close. So you have tables in SQL. You are just kind of querying, getting data, manipulating the table and all that. That's basically what you do. So these tables are organized into columns and rows. You already know that. Whenever I have tables, they are basically always into table. This is the column 1, column 2, column 3, column 4, column 5, column 6, row 1, row 2, row 3, row 4. So whenever you talk about tables, you're talking about rows and your columns. You already know that, right? Then the table represents various aspects of the data, such as the store name, customer name, product, this is what the table represents. Each column represents a specific type of information. So remember, you're talking about this is the table. This table is talking about different column and row, right? Then this is a column. Each column contains one observational unit of information. This is the order ID. This column is talking about only the order IDs. This column is talking about the dates. Everything you see under this column is the dates. Here it's talking about the quantity of that goods. Here it's talking about the product price, just like that. So you can see this is the sales price, this is the customer ID, and so on. So each column represents a specific type of information, maybe the customer name or the date. And each row represents specific instance of that information, such as the customer's name or the row. So now, this is the order date, the column. The column name is order date. And each of this row has to talk about that order date you talked about that the column is. Here is the order date. The column name is order date. So each row has to be a date, right? This is a date, this is a date, this is a date in each row. Hmm? So this is quantity. Each of the row contains quantity that was, so this is like a title. Under the title, you must have those instance of that thing, that title, right? So this is the sales price. Inside the rows, so the row talks about the instance of the title. This is the price for this particular product. This is the price for this product. This is the price and all that. So that's basically how I think we already know all of these ones. So SQL allows us to extract data from the table by writing queries that specify what information we want to retrieve. This is it. This is all about SQL for you as a data analyst. SQL um, allows you to extract data because this database is just like, let's see, let me try to search Google. Let's go to Google and see if we can find let me like give you a picture of okay, let's say database. Just type database so that you can see um how it looks like. It's just a normal hell. This is exactly how database, or let's use this one is more complex. This is exactly how it is on the cloud. You can see, or let's use this one that's more scarier. This is scarier, yeah. This is exactly how it looks on the cloud. um okay, let's use this one. So this is your computer here, and then you have this is a cloud, AWS. You have your Google Cloud, you have Azure, you have Microsoft. All these are cloud hosting companies, right? So this is how it looks. This is a database. So you now have, okay, this is Snowflake, this is data bricks, these are just a, this is data platform, these are data platform and all that. So your computer can allow you to access this database. Relational database, you have Oracle, Microsoft, you have Postgre. These are different the relational database management system that you can use SQLite, you can use MySQL, you can use Postgre, you can use Microsoft SQL Server. This is one we're going to be using. Then you can use Oracle and all that. These are all management system. But now you can see this is the cloud that the data is. This is a cloud. This is a platform you can use to, like SQL that MySQL that you can use to access it. Then this is your computer. Let me look for an easier one. Now look at the exact way that this thing is. These are different databases in the cloud. Look at different companies, different people's database. These databases contain all the information. So this is now the database are working like, this is not the way it works, like a working database. You are not seeing anything that is there. Then this is you now, your computer. You can access, query the database. If you query, this is the way it is stored, different tables in different databases. Now, when you come here and query this database, it will ask you the exact, the specific data that you want. This is like the security system here. You cannot just jump into here and start, having access to any of these database that you want. No, you must pass through this security system that will ask you first, just like you walk into an office, into a federal ministry of maybe Federal Ministry of Health. The first point of call is the security post. After you park, they will direct you. In fact, they'll be the one to direct you where you park your car. I think yesterday, was it yesterday, on Monday, on Tuesday, I went to do something at the police force headquarters in Abuja. So it was, in fact, to get into the building was difficult. You have to pass through the first checkpoint, the second checkpoint, and the third checkpoint. The first checkpoint was the people that they have to know where I'm going, what am I coming here for, and all that. After I was cleared, the second point was they now told me where to go and park my car. They have to send me to where I need, because they have different parking space for their bosses, they have for the top men, their officers, they have the one for staff, they have the one for ordinary people, like normal people. They call it public parking space. So I have to go and park my car there, then come back to the gate. They have to screen you again, assess you, collect your devices if you have a phone or something, then give you a tag that will direct you to the main office where you're going. So even in normal real life, this is exactly how it is also. If you go to a bank, the first point of call is security, right? They will now direct you, tell them what you want to do. Do you want to make inquiries? Do you want to deposit money? Do you want to withdraw money? They direct you to the exact point where you go to. So this is you now, your own computer, you as a data analyst. You're now going to query this database here. You query the database and tell it that I want to get customer information. Then this is now the one that will route you to the customer table here. This is customer table. You can see that the interaction is between you, the customer table, and the database. Now, this database has no business with these people. These other ones are there sleeping. They don't have any business with you. Since you said you want to get customers, they'll just take you to only the customers table. If you tell it that, okay, I want to get customers stable with the transaction they did, it will now say, okay, no problem. It will link you up to these two based on the query you have written. You're the one that will write the right query to tell you where you're going. It will now link you up to these two. This is the customer table, this is the transaction table. So it will now be supplying you information from these two tables. Are you getting the picture, please? Hello? Is any person, everybody understanding? Do you understand
Yeah,
what
we're
is?
following, sir.
Okay, good.
You're following.
Okay, great. So this is exactly how this thing work. So if you now tell you, oh, I want to get information about sales, you say, oh, sales, okay. It will disconnect you from these two table that I gave you, formally gave you access to, and now link you to sales. If this is the sales table, it will now link you to sales. You can now only see sales. Do you get the point now? So this is how SQL actually works. So there can be so many tables. You can have hundreds and millions of tables, but you cannot access all of them if you don't have to. While you're accessing this one, the rest are just resting. You don't have to call them up or wake them up for any reason. You get? So that's how beautiful SQL can be. Um, so this is just like a picture of what we are trying to talk about, and all that. So this is how the database looks like. Uh, there can be so many databases that you can access. All right, so many of them. Look at this one. These are all. This is now you, the user. All right. Then this is the application server. It's like the security system that will now lead you to the particular database that you want to access. Okay. So this is just it. This is just it. So it's basically about tables. It must be about tables, okay? Then you have the SQL allows us to extract data from the table by writing query. So depending on the kind of query you write, it will now direct you to the particular table you want to, the specific table. So for example, we can use SQL to find all the film in Circular. There's a particular data set called Circular data set. I think maybe in our next class we are going to load that data set. Let me see if I have it. We are going to load the data settings. Okay, this is a circular data set. So you can see this is exactly how SQL is. This is the table. Then this is general table. Then these are different tables inside this big circular data set. It's actually a rental, a movie rental data set that that we are going to explore. So they rent out movie to people. So, but inside that you have your actors. You have a table that has only actors' name. So you can come and say, okay, I want a movie that was acted by maybe Van Vika or by Michael Scofield. They'll just come here and search for only Michael Scofield to bring out all the movies that featured Michael Scofield or any other actor that you want to. So if you click on the actors table, you can see this is the table that contains only actor. It has the actor's ID, the first name, the last name, and all this and all that. So you can see a little bit of description and all that. Then the address, you can even see the one that contains only address. You can see the one that contains only category of movies. You can see the one that contains city that the movie was acted in. You can see that. You can see the one that contains the country of the movie. So you can see, okay, I just want American movies. You're going to have access to only American movies. Maybe you want Indian movies, you love love. You want maybe South Korean movies, if you want Nigerian movies and all that, if you want Ghanaian movies, then the customer, you have the film. So this is the film, the different title of the film, the year it was released, the description, and all this. They have the film actors, the film, and also this is even the language. If you say, okay, I want movies that are in Chinese language, it will filter out only movies that are in Chinese. If you want movies that are only in English, you don't want any other language, it will bring out movies that are only in Chinese. Okay, so this is it. This is called the circular data set. We are going to explore this data set and see all of these things, but this is how SQL handles them table by table by table. It doesn't combine everything together. Okay, so that is basically it. So you can say, for example, we can use SQL to find all the film in the circular data set that were released in 2020, in 2006. So it will show you all the movie released in this year. We can also use SQL to combine data from multiple tables and calculate statistics such as average, rental duration, and the total revenue generated by the specific film. So this is just normal analysis you can use your SQL to do. But before that, let's talk about so this is just about the relationship. So let me quickly show you that now you may begin to wonder, okay, how are these things related? I've shown you how they are related, but the most common way that they are related is through what we call foreign keys and primary keys. All right. So the primary keys, when you come here, you can see the primary keys are these ones. You can see the primary keys, like we mentioned in Power BI, that they are not duplicated. You cannot duplicate primary keys. So when you come to this table, you can see that the customer ID here is just one. This one is two. So whenever you see one, you know that it belongs to Chris. The customer ID that owns this ID one is Chris. There can never be another Chris in this table. Can you hear me now? Samuel, can you hear me? Can you hear me? Can you hear me, Kiki? Can everybody hear me?
Yeah, yeah.
I can hear you now.
Okay,
It's
okay,
better now.
okay, okay. Thank you. So you can see that the customer ID one belongs to Chris. There can never be any other Chris, even if no matter even if you come here now and I have, let's say you have 4 and the person is Chris. Now it cannot be the same Chris. There can be so many Chris, but this person may come from Ghana, something like that. So this is definitely another Chris. If you're talking about this ID one, it belongs to this Chris. It is basically this Chris in Nigeria. If you're talking about product ID one, it belongs to laptop. It means it is laptop. There can never be another. So this is primary key. In this table, you can see that there are primary keys. But if you come to this customer ID in this other table, you can see that this customer ID one repeats itself. So here it is called foreign key. So primary key is a unique identifier of an item in a table. You can use this primary key to identify the customer name Chris. You can use primary ID 2 to identify the customer name Marco. So if you want to know the customer number 3, you can know that Cindy. They cannot repeat, right? So, but a foreign key is used to identify or to relate or to connect to the primary key in this primary key table. All right, so they are related with keys called primary keys and foreign key. That's how they are related. So you need to know this. It is very, very important in SQL. Table relationship is very, very important. All right, so your foreign keys can duplicate. You can have multiple because uh, I am actually the customer ID one, Chris. There can never be another customer ID one again in this table, right? But I can buy something as many times as I want. I can come today and buy something. You can come down here now and have another one again that is me in a different date. All right. So let's say let's populate it. You see, this is another date. Then maybe the quantity I bought is just maybe 2. Then what I bought is 300. And then the sales price can be 310. Then customer ID. Now this customer ID is where the whole magic happens. The customer ID that bought this item is what? Chris 1, because my ID is 1 here. Do you get that? So I can buy as many times as I want. My ID can repeat here. In fact, each time I buy anything, it's my ID that will come here. But my own, in this dimension table, which is this customers table, it is just me. I cannot repeat. All right. That is the relationship between these tables. So you have to pay attention to the relationship for primary key and secondary key. All right. And that's all about that. So let's talk about data, because I want to cover everything about theory today. We just have about 20 minutes to go. Then let's talk about table relationship. Sorry, data types. This is another important aspect of SQL that you must have to know. The data type, because you'll be dealing with data. Of course, there's no way you can deal with data in structured data in a table without knowing their type. All right. So obviously from here now you can see that we have the data type here is what? Voucher. Or because this talks about the ID. Anytime you're talking about ID, you're talking about voucher. Or they can be text as well, but you can see these ones are number. Some you can see QR001, QR002, depending on, so, and all that. So here you can clearly see that this is data type. So you must have to, because while uploading or while importing your data into SQL, you must have to specify the data type so that SQL will know how to handle each data that you give to it. All right. All right. So though SQL most times will help you to do all of that, though, just like Power BI helps you to connect the tables and their relationship. So most times it will help you to to do that. All right, but just to be sure, you have to cross check. Sometimes, it's guesswork. They just look at the columns and try to guess what type of data. Sometimes they can go wrong. So you as the analyst should know how to correct them. So these are the different data types you are definitely going to meet in SQL. It's the same type you've met in Power BI and Excel, but it was not really pronounced in Power BI. It was not so loud. But now in SQL, where you're paying more attention to each data type, it is going to be very, very pronounced and you need to know them. So the first one is your numeric. The numeric are just the basic data type that you always meet every day. In fact, you can never work on any data set without meeting numerics. Numerics are simply your numbers, right? That's so obvious. There's no data type that will not have columns with numbers. It could be sales, it could be profits, it could be tax, it could be VAT, it could be so definitely there will be columns with numbers. So, but in this number type, you have the integer and the float. I believe we still remember that. Your integer is just your normal whole numbers, your 1, 2, 3, 4, 500, 1,300. Those are integers. Then floats are numbers with dots, with the one that has points, decimal places, your floating numbers, right? You still remember. So if you have 100.23, 7.94, 9.99, those are all floating numbers. Okay, so the next one is your character strings, or your strings. Just call them strings, or in Excel we call this string. Who can remember what these strings were in Excel? Who can remind me what name we call them in Excel? Anybody? Or even in Power BI too? Please quickly remind us what the name was in Excel. These strings. Can you remember?
I
Uh,
think string is also string in a say. Maybe if you want to use a particular function, like a text function, if you put it in a column, what do you call it? In a bra, as in a what do you call it? And in a comma, upper comma, then it becomes a string. It now acts like a number. A text acting like a number in a say. I
okay,
don't know if you
so
get me.
that's correct. That's correct. So both in Excel, both in Power BI, both in Python, both in SQL, strings are strings, okay? But in Excel we call them text. It's just text. I think we call them text in Excel. So if you put a quotation mark above them, maybe is that one is more pronounced in Python. When you want to convert anything to a string, you just put them in quotes. So, but strings are the same thing as text, your normal text, like name, your customer name, anything that has to do with name. All right. So these are strings. All these ones are strings. Let me show you. So all these ones are string. This is a string. This column is string. It contains names. This column is strings. This column is string. I think there's no string here in the big distance. These ones are strings or text. You can also call them text. Obviously, they are text. But this one is not. This one is numeric. You have numbers, right? So that is how you. But in Excel, you call them. Sorry, in Power BI, you call them characters or voucher, car or voucher. So you call them voucher, you call them text or characters when they are small, like you have name, maybe Chris, Edna, you know. But when you now have them longer, when you have them longer, you can call them voucher. So you sometimes you call them voucher 50s, voucher 225, depending on when we get there anyway, we're going to see them in practice. Then you have your Unicode characters. These ones are not really popular. Where you have your end character or your end text. This is still talking about strings, right? But this is the most popular one, your char or your voucher, okay? In fact, when you're the one creating the table, because you can also create table from scratch in your SQL. If you're the one creating the table, for you to create any table, you have to specify the type of data that will be in that column. in each of the columns. Sorry, you have to specify the type of data, the data type. That is where this thing comes into play. Or when you want to modify a table, maybe you want to change the table name, sorry, the column name. So you have to specify the name of the new column, the new name you want to give it, and the data type is going to carry. So you must have to know all of these data types. Then you have your binary, the binary and the image. So this binary is not really popular also. You have your image. This one handles image. I think they call it Bob, B-O-B. It handles image, handles videos and all that. Then your date and your time. Remember dates. We already encountered dates in that previous data set I used as an example. So you need to know the difference between date and date time. So your date has only the date, while your date time has both the date and the time. And then miscellaneous, these ones are not common. Your JSON file, this one is when you're getting data from a website. This is what data type is going to be. But they are not really popular. Most of your data is going to fall under numeric, your strings, or date time most of the times. Okay. So now let's talk about relationship. We mentioned relationship in that data set I just mentioned to you, where you have your primary key and your foreign key. So you need to understand how this schema is called schema, how this thing work, how your tables are related. Your tables are related. In fact, when we get to join, when you need to start joining table, this is where it comes in handy. It becomes handy because you need to know which of the tables should be in the left or in the right, which of your tables should be the primary key or the this key 10 and all that. So you can see that the other table is linked to the other item, and the other item is linked to the product, and the product is linked to the merchant, which is the customer is linked to the orders, the order is linked to the users, the user and the customer is linked, the user is the country. And you see, so this is very important. Now you are not the one that will create all this relationship. Remember, like I told you, you are not the one, because all of these things someone else will handle. There are people, the data engineer will build these pipelines, and then the data administrators are also there to give access, to give permissions. Your own is just to query, but you need to understand what you're querying, right? That's why we need to do this. Even in that secular movie data set I told you about, let me see, you're still going to this is it. You see this secular data set. Let me even just, I think I have the schema diagram of that movie data set, so that you can understand what I'm trying to show you. This is it. Here, this is the schema here. You can see the schema of that data set, the secular data set. You can see the actors, that table I showed you, the different tables, all the table, no matter how large, how plenty the table is, all of them must be linked to each other. You can see all of that table I showed you, the category table, the film category, the language table, the actors table, the filmed actors, the film, the staff, the inventory, the payments, the customers, the rental, people that have rented, the country, the city, the address, all of them are linked. You can see. So this is linked to this is linked to this. This is, if you remember our Power BI, you can see that this is a single kind of link, and it says this is from one to many. This is coming from one connected to many. Here from the sign you can see many to one and all that. So this is called schema, right? I think we did this extensively in what is it called, in Power BI. I explained this in detail so you understand everything about schema. So it's just a kind of table relationship. You don't need to bother yourself about this. It's not your business. But there are so many kind of schema, but the most popular one is the star schema. The star schema is the one where you have the fact table in the middle, then your dimension table. So the fact table is just a table that cannot it's just a table that cannot change. Sorry, the one that keeps changing, while your dimension table are the ones that cannot change. So the data you have here keeps changing and all that. Let me explain it with this one. So you can see that this is your fact table. This is a fact table, and this is your dimension table. So your dimension table most of the time has the primary keys, right? Your dimension table has the primary key, while your fact table has the foreign keys. So the reason is because the information you have here are static, they cannot change over time. Mm? They cannot change. So you can only have one crease here. That's does not that for you to have a new customer here, you have to come in with a new customer ID and they are not duplicated. But here, one customer can buy as many items as they want. I can decide to order a new item now and new information will come in. So this fact table keep changing, adding information, while the dimension tables, they don't really change. They contains the primary key, while this one contains the foreign key. So this is called star schema. So here you can have this is like the main table. Then you can have the customer table. Here can be the product table. Here can be the store table. Here can be the sales table. Here another you can have another one as the country table. You can have the transactional table, as many as that. And this is just the facts, okay? So we also these are different commands that you're going to meet. We're going to be using in SQL. The different commands. I have your like this basically all the things you can do with SQL. So this is data query language. This is the data definition language. This is the under the data query language you have your select. This select is a very powerful language in SQL. When you write select, it means you want to see the content of a table, right? So then your data definition language, you have create, you have drop, you have alter, you have truncate, you have comment, you have rename, you have delete. There are so many. This is the one you're going to be using to manipulate data in database, all right? All these commands. But this is the one you're going to use to query the database. So, and then this is the data control language. You have to grant, revoke. This is, data just like the name imply control. This is the one that the data administrator uses to give access to everybody. You can give access to what you can do in the database. So, and then the data manipulation language, you have to insert, the update, the delete, the lock. So you can use insert. You want to insert a new information, a new data into the table. You want to update the table. Maybe something has changed. You want to update an address, or maybe you want to change the column name or something, or you want to even delete a column entirely or lock and all that. You can use this one to manipulate. Now, all these languages, like I mentioned in the control, the data administration uses this one to give access or that. You as a data analyst, where do you come in? This is the only place you are limited to in this select language. This is mostly the only thing you're going to be using. You cannot go and delete. If you go and delete the data, if you mistakenly now you can go there and delete an important information and then you end up in jail. They'll lock you up. You can go there and delete maybe an important row. You can go there and delete the table that contains sales from 1995. You can go there and delete something that. So in fact, you'll not even be able to get to the point of using delete and drop or alter, because this person now, database administrator, will not give you that access. They can only give you access to query the database and get the data you want and start analyzing it the way you want it. So you can actually create a new table, because in case you don't import, because most times they will give you just query data set and get the data you need. But this is to show you that you can also create a new table in Power BI. Though you don't have the access to do that, you won't be the one doing that. It's just for you to go and the tables are already created and formatted and structured. It's just for you to go there and query it and get what you need. Okay. So this is where you may be limited to as a data analyst. Just go get the data you want and start doing your analysis. And after doing your analysis, you now move it to either Power BI or Excel or wherever you want it to do your visualization or do whatever you want to do, or maybe to Snowflakes or wherever. But Power BI is not used for any other thing. You cannot visualize, you can't do anything there. It's just to query the database and collect the information you want, analyze it the way you want. Maybe you want to combine the two different tables, just get it. I think in a particular project we are going to do, we are going to see how to, link Power BI to SQL and then get data from SQL and move it to Power BI and visualize and do all of that. So this is where your superpower ends. This is what you're going to be doing, okay? But however, we're going to touch on all of these things. We're going to use all of these things to see how to use all of them. Go ahead, Marco.
Okay, thank you so much, sir, for giving me the opportunity. I'm grateful, sir. I understand what our lesson talks about today. But sir, I wanted to highlight on one thing. The project we did recently before we just started this SQL lesson, I encountered a challenge, or is a major challenge, I can say, which is how to do DAX function, that DAX, because I noticed that so many things there, mostly the KPIs are needed, and I had to create a DAX for it. And to be frank with you, I use AI to generate it, some of the DAX, and I believe and I think it will more is better for us to learn how, I think, get a brief knowledge of how to do DAX in Power BI. I don't know if you can do that. Just if you can just go back a bit and just introduce DAX for us so that I can easily do and stand out
Okay,
maybe tomorrow.
did you miss the class on DAX when we did it?
DAX, though I missed class, but I watched all the recorded this thing.
Okay, no problem. We can have a class on DAX. DAX is actually now the thing is you cannot learn everything about DAX because you don't always need it. But the secret is that if you understand the concept of DAX, then you understand the basics how to use DAX. Then the actual thing you want to do, because you cannot learn how to do everything, the particular thing you want to do depends on the circumstances or the situation or the project you're working on. So there's no way you can learn how to do that for everything, for all projects. It depends on the requirements. And the secret is that whenever you're working, whether you're programming, whether you're building software, whether you're doing Python, whether you're doing SQL or Power BI, the online is your secret heaven. AI is your secret haven. That's where you always go to. Because me, if for example I don't know anything about data analytics, I don't know anything about Power BI, I cannot use AI to generate anything. It will not make sense to me. I don't even know the question, the prompt to give AI. But because you study, you know Power BI, you know exactly what you want to do. You're able to give AI the right prompts to generate a particular DAX for you. Then even after generating it, if I don't know how to use it, I still don't know. But you, because you are a data analyst, you know how it works. Then you can now be able to pick up that, copy that prompt that the AI has given you and know how to use it and get the results you want in your DAX. Many a times, I don't have to know the DAX myself. I have to just use AI. The AI will write it, then I'll know how to now modify it and achieve exactly what I want. So, what you did is actually the right thing by using AI and being able to integrate it into your own projects and do what you're supposed to do. But however, we are going to have a class on DAX basically. Maybe one of those classes will not treat. It could be maybe next class or something. Or we can fix a different day and then handle many DAX problems. So that a lot of people can know how to use DAX. Even if you're using AI, you know how to apply it and how to do all of that. Are you okay, Marco?
Okay, sir. Thank you so
All
much.
right, all right. So that's it. So that's it about that. Then finally, I think we are done with this class for tonight. Yeah. So in our next class, we're just going to jump into writing queries and doing amazing manipulations with SQL. SQL is actually amazing. It's like the simplest of all these things we've done. We've done the hard part already. SQL is just like writing scripts, doing a lot of things that you want to do and all of that. So we'll just take questions right now and